Hi everyone, today we're going to do lesson 4.5, part A, writing function rules. We're going to write function rules to represent a real life situation. As always, feel free to pause the video if at any time you need to stop to catch up on your notes. Let's just do a quick review of what some math symbols represent. When we see the word of, we should think of multiplication. Is, we should think of equals. Product, again, multiplication. Quotient, we're talking division. Sum, addition. And difference is subtraction. So let's write some function rules that represent situations. Y is less than the product of 4 and x. I misread that completely. Let me try it again. Y is 5 less than the product of 4 and x. Well, if you remember our less than, that is subtraction, but it's also a turnaround word, as you recall. So that's going to have to come after this. So we have y is, I kept wanting to say less than. How would I show the product of 4 and x? Well, that's going to be 4x. And if it's 5 less than that, then we're going to subtract 5. So y equals 4x minus 5. Let's try our next one. C is equal 8 more than half of n. So we know more than is adding, and we're talking half of n. So you could do 1/2 n. Now, even though our addition and is commutative, so 8 more than, I want you to get in the habit of writing our number without the variable at the end, like this. So I'd have C is 8 more than half of n. They're the same thing. Just kind of like to get in the habit of having our variable first. You'll see why in our next chapter. My next one, I have 7 less than 3/5 of b is a. Well, I have is a at the end, so it's going to equal a. Again, I have that less than, so that's going to be my turnaround words. Turnaround. So I'm subtracting 7 from 3/5 of b. 3/5 of b will just be 3/5 b. We're going to take 7 off of that. Subtract 7. 7 less than that is a. Kind of written goofy, but get the idea. And my last example, 2.4 more than the quotient of h and 3. Quotient, that's division. So the quotient of h and 3 can be h over 3. Just like I said before, I could do 2.5 plus this, but I like to get in the habit of having my numbers, my constants at the end, my variable in the front. So 2.5 more than the quotient of h and 3 is w. I'm actually going to try to get you in the habit of writing this in the front too, but we'll deal with that later. Let's look at our next situation. I have a kennel that charges $50 per day to board dogs. So if I say 1 day it's $50, 2 days $100, 3 days $150. Notice this is where I'm multiplying. I'm multiplying $50 times my number of days. Upon arrival, each dog must have a flea bath that costs $12. They don't have to have a flea bath every day, just when they get there. We want to write a function rule for the total cost days of boarding plus a bath. So let's look at this. If I don't stay any days, if I just show up, it's my first day there, I haven't stayed at all yet, I'm having a bath, and it's $12. Well, I'm not having a bath, my dog is. If I stay one day, I'm going to have $50 plus a bath, so it's going to be $62. If I stay 2 days, it's going to be $100, 2 times 50, plus that $12, so $112. If I say 3 days, that's going to be my 3 times $50, $50 every day, plus my $12, so that's going to be $162. My function rule then is my cost, doesn't tell me a letter for cost, so let's just put Y, is going to be $50 for every day. It did say to use D for days. I could have put a C here for cost. I probably should have. Plus that $12 bath that my dog has to take. Now it says, how much does a 10-day stay cost? Well, I don't want to make my table all the way out to 10 days, but I can figure that out because my total cost, my Y, equals $50 times my number of days, which in this case is 10, plus that $12 bath. Well, 50 times 10 is $500, plus my $12 bath again will leave me with a total cost for a 10-day stay of $512. So it says, how much does it cost for a 10-day stay? It's going to cost $512. Notice when I write my tables and things, I usually don't put my dollars in there. You can. I try to keep them a little cleaner, but it is part of my answer. Okay, my next example says I'm writing a function that represents this situation. The price of a pizza, price, P, is, oh, look at that. It has that nice is in there. I know that equals to $6.95 plus 95 cents for each. Each is the important word, topping, T. Each, you're talking multiplication. So if I get one topping, it's 95 cents. Two topping, it's 95 times 2, or $1.90. So this is my multiplication and multiplying 95 cents by each topping. Like I said, I like to start with my variable. I could put my $6.95 plus at the start, but I'm going to write it as my cost of my pizza is 95 cents for each topping, 0.95 for each topping, plus my $6.95. If you did 6.95 plus 0.95t, there is nothing wrong with that. Just when you start working on things, next chapter, you'll appreciate having this order. So here is my price. The total price as a function of the number of toppings, price equals 95 cents per topping plus $6.95. I forgot to clear my screen. Okay, here I have a situation. I have an airplane and it's 30,000 feet above the ground. So that's where it's starting from. It's starting from 30,000 feet above the ground. So it wants to know it's descending at a rate of 2,000 feet per minute. Well, descending means it's going down. It's going down 2,000 feet per minute. We're going to talk about the situation. So when we start, it's going to be 30 feet above the ground. 30,000. Did I say 30 feet? 30,000 feet above the ground. Pretty big number. But it's descending 2,000 feet per minute. So 1 minute later, it's going to be at 28,000 feet. Hopefully it's descending on purpose. I think it is. I think it's just landing. 2 minutes later, it'll be at 26,000 feet. And then 3 minutes, 24,000 feet. So you can see my y, my change in y over change in x pattern will be 2,000 over 1, or 2,000. So my height will equal, notice it's descending, it's minus 2,000. Going down 2,000 feet for every minute. And we're starting from a height, and is height the right word? Elevation of 30,000 feet. So that's when our time is 0. The time 0, or the start of our function, we're at 30,000 feet, and our rule is we're going down 2,000 feet per minute. Now this is an interesting question. It says, after how many minutes? So we want to solve for minutes here. Will the plane be on the ground? Well, when the plane's on the ground, what's my height? My height will be 0. So at what point is 0 equal negative 2,000 m? We're solving for m. Minutes. After how many minutes? Plus 30,000. This is just a regular two-step equation. We've solved a million of these. Maybe not a million. Slight exaggeration. So I'm going to subtract 30,000 from both sides. Because my goal is to get that m by itself. Find out how many minutes. It's a lot of zeros to write. Minus 30,000. Should move that over a little bit. So I have negative 30,000. Equals negative 2,000 m. Last step, I'm going to divide both sides by negative 2,000. And how long will it take this plane to land? Negative divided by negative is a positive. 30,000 divided by 2,000 is 15. So 15 minutes after it starts descending, it will be on the ground. Okay, I have another situation. I have Lynn. She's tracking her plant's growth. Today her plant is 5 centimeters high and it grows 1.4 centimeters per day. Multiply my 1.5 times my number of days. I want to know its height as a function of days. Well, my height will equal my 5 centimeters plus my 1.5 centimeters per day. So it's going to be my 5 centimeters plus my 1.5 centimeters every day. Now, like I said, I like to rewrite this. I like to have my variable first. So my height will equal. That way it's easier to see that this is my y over x pattern. And this is the starting point of my function. It's 5. What will it be after 20 days? I'm just going to substitute 20 for my number of days. So my height will equal 1.5 times 20 plus 5. 1.5 times 20 is 30 plus 5 will be my height. My height will be 35 centimeters. Oops. Another situation. I'm writing a function that represents this situation. Joe works at Cherryberry. Not my son Joe, different Joe. He earns $9.25 per hour. Again, that per, that's a clue that that's what you're multiplying. And we're writing a function in terms of hours. It says write a function how much he earns. Well, there is no starting. He doesn't get like money right away before he works. He doesn't earn anything if he doesn't work. So we want to know how much he'll earn. Let's say E. Why not? He will earn $9.25 for every hour he works. Now, my next question is how many hours will he need to work to earn $100? Well, that means if it's $100, we want to know how many hours. $9.25 for every hour. I just need to, it's a one-step equation. I just need to divide both sides by 9.25. And I have 100 divided by 9.25. It'll give me a weird response, but H number of hours will be, it comes out to 10.81, which is a very peculiar number. It's actually 10.810810810, but we'll just say 10.81 hours. But generally speaking, we'd probably say he needs to work about 11 hours to have his $100. That's it. Have a great day. Talk to you soon.